In this video, I'm going to talk about molecular shapes. So the way a molecule is shaped is based on this idea called the VSEPR theory. And the VSEPR is an acronym that says valence shell electron pair repulsion. So essentially what that does is it predicts the three-dimensional shape that a molecule is going to have when atoms are covalently bonded. So the name tells us that the shape is actually determined by the valence or outer shell electrons, and the fact that because electrons are all negatively charged, they actually repel one another. And so what they do is within the molecule, they try and evenly distribute themselves or spread out as far as they possibly can from one another in the molecule. And this tells us the angle at which the bonds form for that molecule and therefore the shape. So I'm going to discuss just 5 basic shapes and just give you some tips on how to identify from a formula what shape a molecule actually is. So the 5 I'm going to talk about are linear, bent, trigonal planar, trigonal pyramidal, and tetrahedral. So let's start with linear. Linear is a molecule that is one of two things you can identify from the formula. It only has 2 atoms, so like HF, hydrofluoric acid, or HCl, hydrochloric acid. Each one of those only has 2 atoms. They have 1 hydrogen and 1 chlorine, or 1 hydrogen and 1 fluorine. Also, linear molecules are ones that have a subscript of 2 and contain a group 4 element as the central atom. So carbon dioxide is an example of that. So carbon is in the middle here, and it's in group 4, and it has a subscript of 2, so CO2. So when you look at these formulas and you identify it as being linear, you know that it's going to have the three-dimensional shape of being a straight across line. And that angle is 180 degrees because it's 180 degrees around this bond, from this bond to this bond. Now the next one is bent. So molecules that are bent are ones that also have a subscript of 2, but these contain group 6 elements as their central atom instead of group 4. So if we look, water is an example of that, and you see oxygen is group 6 and it's in the center, and then you have hydrogen here and hydrogen here. And essentially what it does is, because it's a group 6, you have these sort of unshared pairs of electrons that are repelling and pushing the hydrogen in this direction. So for the bent shape, which also looks like this here, the angle between these 2 bonds is actually 105 degrees. All right, next we have a trigonal planar. So a trigonal planar is a molecule that has a subscript of 3 in the formula, and as the central atom, it contains something from the boron group, which is group 4 on the periodic table. So you can see here it's a flat, one-dimensional, and these 3 make a triangle on like a flat surface. So that's why it's called trigonal planar, because it's one solid plane. And in between these bond angles here is 120 degrees for a total of 360, right? So 120 between each bond. Now next we have trigonal pyramidal. Okay, so this is a little bit different than trigonal planar. Trigonal pyramidal is more of like a 3-dimensional pyramid. So you have a pyramid base, and then you have up here at the top you have the central atom. So the trigonal pyramidals you can identify from their formula because they have a subscript of 3 and they have a group 5 element as their central atom. So nitrogen is in group 5 and it has a subscript of 3, so you can identify it as trigonal pyramidal. And the angles here between these bonds are 107 degrees. So if you look at, this is sort of the Lewis structure for ammonia. So you have the hydrogen pairing here, and then you have a hydrogen pairing here, and a hydrogen pairing here, and then you have the single unpaired electrons, so they're sort of up here repelling these down away from it in the opposite direction, creating this pyramidal shape. Then the last kind is a tetrahedral. So tetrahedral, if you see a formula and there is a subscript of 4, you can consider it tetrahedral. And a tetrahedral is a lot like if we look back up at the trigonal pyramidal. It creates a pyramid on the bottom, but it also has an element coming up off the top of the central atom. So you can see here there's 1, and then 2, 3, 4, and these 3 forming like sort of the triangular base. So this is tetrahedral, and the bond angle for tetrahedral is 109.5 degrees. So in the classwork activity that you're going to be doing, you're actually going to be using a simulation to build molecules and sort of look at their shape and get an idea of their three-dimensional shape. But you should be able, from the formula, be able to determine the molecular geometry based on just those little tips that I gave you in this video.